Ladies and gentlemen, please welcome to the stage global leader, worldwide public sector marketing, Amazon Web Services, Tricia Davis Muffet.
Hello, public sector. I think we have the whole public sector universe here today. Thank you so much for coming out to spend a couple days with us. I just want to give you a few thoughts to make sure that you can make the most of your time with us. We have put together an incredible 2 days packed with content that I think you're going to really love, hearing about all of the amazing things that all of you are doing with our technology. To make sure that you can find the sessions that are most relevant to you, please download the mobile application. You can search in your app store for AWS Summit 17 and you'll find the right thing right there. Also, when you're in the sessions, please fill out the evaluations. Those are in the mobile app and on paper. We really want to know what you think so that we can make sure that we give you the best content possible. Also, please mark your calendars. First of all, you do not want to miss the parties going on here. At 5 o'clock today, we have a welcome reception going on in the exhibit hall back here, and we have an amazing closing party scheduled for you tomorrow at 5 o'clock, so please join us for those. Also, I hope you noticed we've already got the dates published for the 2018 Public Sector Summit. So please mark your calendars and make sure you can be here June 20th and 21st next year. And if you're joining us from around the world, which I know we do have people from lots of countries around the world joining us, please join our public sector summits that are making a world tour. So we'll be in Canberra, Australia, Singapore, we'll be in Paris, London. So please find us in those locations. We'd love to talk more with you there. And also, I want to make sure that everyone takes time to visit our sponsors in the exhibit hall. I'm sure you saw the great displays that they have set up on your way here. And I would be remiss if I didn't thank our top sponsors who really make this all happen. So thank you so much to Intel, who is our diamond sponsor, and then also to our platinum sponsors, C3 IoT, Cloud Checker, CSRA, Deloitte, Smartronix, and Telos. Thank you so much. And also Accenture, who is the platinum sponsor of our executive program. So let's have a round of applause for those great sponsors. Also, please take time to visit our gold sponsors. They have lots of great things going on. They're speaking in the sessions. We also have our silver sponsors who have great things to show you in the exhibit hall as well as in the sessions. Bronze sponsors, too many to name really, but they are here with us in force. I hope you will spend lots of time with them. And then our media sponsors who helped get the word out to all of you. Thank you so much. Can we please have one more round of applause for all of the sponsors? All right, thank you very much, and let's get ready to have a great time.
Never been a better time to build. So go build, have fun.
Ladies and gentlemen, please welcome to the stage Vice President of Worldwide Public Sector, Amazon Web Services, Teresa Carlson.
Wow, wow. Whoa. Hello out there. It's amazing. I can't believe it. It's great to have you guys out here today and just to see you here networking, coming together, getting to know each other. We have an amazing lineup of everything happening. 9,700 individuals have registered. I actually think that's surpassed 10,000 now, and I think we have about 7,000 that's already shown up today and coming in. We have over 100 technical sessions for you. Are you enjoying your technical session so far? Yes? All right, excellent. And over 95 partners here exhibiting in the hall. I can't believe it. This is looking like reInvent. So it's so exciting. Thank you all for being here today. So now let's do a quick business update before you get to Werner. Let me give you a quick AWS business update. So what's happening with AWS? Well, here's what's happening. We are now at 14 billion in revenue run rate, and we're showing 43% year-over-year growth. It's truly amazing, and it's because of you. It's because of all your support and all your help, and all of you. You really are helping as the catalyst and the mover into cloud computing. We're also proud that AWS continues to be the fastest growing multi-billion-dollar plus enterprise IT company. And as you can see from this chart, there's a real changing of the guard when it comes to IT right now. And as I like to tell a lot of people, we're the very different IT company, being customer obsessed, customer focused, and continually thinking about what our customers and partners need. In the Gartner Magic Quadrant, AWS is positioned as a leader, again, in the most recent one, for the cloud infrastructure as a service. We're the highest in execution and furthest in the vision within the leaders quadrant. So thank you again for that, because you're, of course, a big part of why we are in that quadrant, because it's not only about what we do, but it's about how you utilize and really take advantage of cloud computing as well. So we have millions of active customers per month on AWS. And who are those customers and partners outside of you, of course? Well, we have customers and partners from around the world, customers like Discovery, CSRA, the Washington Post, Digital Globe, Illumina, Warby Partners, Parker, Lyft, Sumo Logic, Coursera, and House, and many more. I recognize so many of these companies up here today now, going around the world and seeing what they're doing, and there's thousands and thousands more. And then, of course, my favorite, the public sector customers. We now have thousands of customers in public sector, some amazing ones that you're going to hear about on stage today with Werner, and tomorrow that you're going to hear on stage with me in my keynote, customers like HHS, CMS, and the UK's Ministry of Justice. So strap in to hear all of our customer stories. And then we have system integrators and our premier consulting partners. We have a really broad ecosystem of system integrators, including partners like Accenture, Deloitte, Telos, and Smartronix. And we also have some of the broadest ecosystem of ISVs out there, like CloudCheckr and C3 IoT. I was just yesterday in our partner breakout for government partners, and C3 IoT was there along with CloudCheckr, and most of the partners there said, we're using CloudCheckr. So it's great to see that integration and how partners are actually really, really working together. But many, many more, and we want you to join and be part of that ecosystem. And how do you do that? Let me tell you a little bit about our ecosystem in public sector. We have thousands of partners around the world focused on public sector. And many of these partners tag themselves to the public sector and say they have workloads writing there right now and solutions that they built. But since this time last year, we've launched our government competency, our GovCloud skill program, and our public sector partner program. And in those, we already have 450 partners that have been recognized for those competencies. So thank you so much, and I want the rest of you to please join in with us. But what's new? What's going to be new in this partner ecosystem? Well, today I'm announcing a new competency, a competency for education. And the partners here have demonstrated technical proficiency and the proven customer success in the education space. So look at the partners that we already have. So let's say congratulations to those partners. Thank you for being part of our education competency. Love this. By the way, partners, we listened to you. You told us you wanted competencies, and we are driving them. So I'm really excited, and I truly do want you to be part of this ecosystem of public sector. And it's important for other reasons. Many of our partners also have their solutions in the AWS marketplace. We have over 135,000 active users on the marketplace right now, over 3,800 software listings, and over 1,200 participating ISVs that actually have their listings today that our customers can take advantage of. But not only do we have marketplace just in our commercial cloud, and we have marketplace in our C2S IC region, we are now announcing, coming in the summer of 2017, AWS Marketplace for the GovCloud US. Now let's talk about GovCloud for a minute. In 2011, we had our customers telling us that we need a dedicated US GovCloud for our customers and our partners. Well, since that launch in 2011, that cloud region has grown at 185% compounded annual growth. Pretty amazing, huh? And you guys continue to use that, many more workloads, including workloads like ITAR, CGIS, FedRAMP, HIPAA, and on and on. And this was because of you. But you told us you needed more than that region, and we listened to you. So today, I'm announcing, coming in 2018, AWS GovCloud US East. So a whole new region for you guys. So now not only are you going to be able to have what you asked for DR and COOP, you're going to have everything you need in the location you need it, including the same services along with DoD, SRG, ITAR, FedRAMP, CGIS, and all the other compliances that matter to you. So thank you so much. Well, again, I have to take a deep breath and say, I'm just so excited to have you all here. And last year, we got to have our CEO, Andy Jassy, with us on stage where he did a Q&A. And this year, I wanted Werner Vogels to come back. Werner is like a rock star around the world. He's really known so much for everything that he does in terms of evangelizing and getting the news out to our customers. He always jokes that Amazon was the first real job because he was a former academic and spent 10 years as a research scientist at Cornell. So of course he loves that we have our Cornell case studies. He also happens to be the original developer of Dynamo, the first NoSQL system. So please put your hands together and welcome with me Dr. Werner Vogels, our Chief Technology Officer at Amazon.com. Thank you, Werner. Come on in.
Thank you, Teresa. Good morning, although, what should I say, afternoon, so we have lunch. Thank you all for coming out here today. This is amazing. I remember 7 years ago when we did the first summit, it was a very small room. I think we had 50 people in there. I think this is quite an amazing change when it comes to this. I want to emphasize something that Teresa said as well. This is not a sales conference. This is an educational conference. The idea is here that you're here to learn. And that there's no better learning than from your peers. So I would really urge you to look at the people next to you over the coming days, because they may already have been AWS customers for quite some time. And there is no better way to get to the truth of what AWS can really offer you than to listen to your peers. And we really urge you to attend many of the sessions where many of your peers are actually speaking and talking about really how they are really using AWS, how it has changed their ways. Now, I think we're in our 11th year of AWS, and I think the impact that we've had on the whole IT industry has been mind-blowing. If you look at a few years back, we already saw that sort of cloud has truly become the new normal. There's no longer a discussion, are we going to do cloud, are we not going to do cloud, are we public or private, and all these other stories around it. Public cloud is the place where you go if you want to build new IT. It's definitely become the new normal for places where you build new capabilities and new functionality for your customers or for your citizens. But also it's become the target for migrating en masse also the functionalities out of your own data centers into the cloud, mostly on one hand for cost efficiency, but also for other reasons. Security, better availability, better performance, lower cost. All of these areas are very important to many of our customers. And so when you talk to developers, after this sort of new normal kind of has set in, developers would tell you that they felt liberated. And I've heard from many of our customers around the world that developer productivity has increased tremendously. 2 to 3x over before. Why? Because nobody needs to wait for resources anymore. Anything you can have in any form with just a click of a button. And so when you talk to these developers, they tell you, you make us feel like James Bond. I go, what? Yeah, you make us feel like James Bond. You are Q. You give us all these new tools, all these new services, and we no longer have to think about how to implement search with Solar and Lucene. You just give us Elasticsearch, you give us Cloud Search. We can really focus on really the kind of cool things that we need to do, and definitely with, for example, all the new AI services, you give us really superpowers to integrate voice and text and imagery into anything that we do. And so it is as if developers have been given superpowers. And these superpowers allow you to completely focus on the mission that you have, on the things that you want to build, on the products that you want to create, on the new systems that you want to serve your customers with. And so I thought that we should go through a number of these superpowers, because don't we all like superpowers that sort of AWS gives you with an idea about how we can help you be successful building the IT systems that you want to build. Now, I always think that there is a #1 priority in anything that we do, and that is protecting our customers, or protecting our business, protecting our government, protecting our citizens. If we do not take security serious as our #1 priority, we don't have a business. It's clear to us that for many of our customers, security is becoming the main priority for them to move over to AWS. There is no line in the sand that says, this is good enough security. No hacker ever looked at the stamp of ISO 27001 and said, oh, we're not going to touch that. Yeah? Security is a continuously moving line. And at AWS, we're able to make investments to continue to stay ahead of that line, whether it's in terms of intelligence or prevention. Many of the actions that we can take are almost for any company or many agencies around the world impossible to make this kind of investments. At AWS, we can make this investment, and that's why quite a few financial organizations, for example, are now moving over to AWS because they can get security at a level that they would never be able to do themselves. So it's 2 parts of it. On one hand, AWS is responsible for what I call operational security, keeping you safe from the network, from intrusions, areas like that. But we also have made major investments into building tools that you can use to do your part of security. Whether there's this sort of do network isolations with using virtual private cloud, making sure you have the right identity mechanisms in place with IAM and other tools. If you have subject to compliance, we give you a range of tools in which you can manage that. And I think in that area, for example, AWS Inspector is extremely important. If you are subject to certain regulations, let's say HIPAA, we give you a whole set of libraries to go with Inspector that will continuously inspect your environment to see whether you are still in compliance. And especially if you run a very agile development methodology where you continuously roll out new code, it is important to know whether you are still in compliance once you've launched your new code. And with all of that, encryption is really becoming the default tool for everyone to use to make sure that you are the only one who has access to your data or who decides who has access to your data. Encryption is becoming the most important tool in security. And in AWS, we have integrated it into all of our services. For example, if you're using Redshift, our data warehouse service, it encrypts all data by default. We have a random key for each data block, and then take that set of random keys and encrypt it with a master key. You can bring the master key, we can generate it for you, but that way you are the only one who decides who has access to the data that you process in your data warehouse. Important in all of this is not just to use the tools, but to think about from day one when you start building things to integrate security into that by design. Security is not something you can sprinkle over it afterwards. It's not a firewall. If firewalls will be the right way to protect your systems, we would still have moats around our cities. We don't do that. We protect individual building blocks. And as such, you need to do this by design. Amazon of AWS really urges our customers to take a look at security by design. Basically 4 different phases. Phase 1 is where you look at your requirements. What are the requirements that you inherit? For example, FedRAMP or HIPAA. What are the cross-service requirements? Sort of what are the other pieces that you need to work together with? How do you do identity and access management there? What are the things that are unique for your customer base? And what are the sort of controls that you get with it, with the kind of operating systems that you use, or operating environment? Then you design your secure environment, making use of access management, network segmentations, resource constraints, all the tools that we give you to implement those requirements. And then make use of templates to enforce the use of templates to make sure that only those pre-approved secure environments can be launched. You can use Service Catalog for that. And then, of course, you do the validation. You can use config rules for that, or against Inspector. So security by design is an incredibly important tool for you to think about how to build secure systems. At AWS, we have a whole website around security by design. I urge you to check it out, including a set of white papers and best guidances about how to implement this. There's one particular threat that our customers, I think any customer around the world, are concerned about these days, and that's denial of service. So let's take a look at sort of the typical denial of service attacks that we see. There's sort of 3 different ones. The most common ones are volumetric attacks, basically flooding the network with UDP or ICMP packets. Then there's the state exhaustion DDoS attacks, that is basically sort of SYN floods that sort of take up resources on the host systems. And then there are the smarter ones, the application level, the level 7 attacks that sort of make use of very unique application-defined resources to attack there. Now, if you look at sort of the division around that, about 65% of those are volumetric that we see around the world, about close to 20% state exhaustion, and a small percentage are really those at application level. We've been protecting you for a long time already, from both volumetric as well as state exhaustion attacks. AWS Shield for everyone, although it was launched at reInvent, we had it in place for a long time already. Every AWS customer gets this. You're all protected all the way up to level 4, as it's called. And if you combine this With the web application firewall, then you can actually also set rules in action that actually protect you at level 7 as well. Now, some of our customers are really concerned about very high-scale attacks at level 7. And for those, we've introduced AWS Shield Advanced, which helps our customers that have these kind of concerns with a 24/7 help desk in DDoS responses, gives you some cost protection in resource usage around ELB and CloudFront and Route 53, and actually includes the web application firewall at no additional cost. So this protects everyone. And this is really important, because DDoS attacks, many attacks around the world, many different types of attacks, not only DDoS, but others. I don't know if you guys saw the intro video, but the city of Los Angeles sees 180 million cyber attacks per day. 41 different agencies, 40,000 different employees, 180 million cyber attacks a day. You can imagine that they need quite a bit of manpower to actually deal with all of this. So they moved many of these protection services over to AWS and run them from there in GovCloud to actually help protect the city of Los Angeles against these very costly attacks. I would like to invite on stage now one of our customers from the UK to share their story about how technology transformation with a focus on security has helped them. So I would like to invite Ian McCormick, the Director of Security Assurance from the National Cybersecurity Centre in the UK, on stage. Ian. Thank you.
Thank you. Thank you. Wow, what a great audience. And thank you for having me here today to speak to you. This is great. My name is Ian McCormack, and I'm one of the technical directors from the UK's National Cybersecurity Centre. I'm shortly going to be joined on stage by Tom Reed from the UK's Ministry of Justice. And what we're going to talk about together today is about how we've transformed our approach to technology in the UK. And I'm specifically going to talk about the role that security has played within that, and then touch on some of the implications for cloud. Now, I'm sure it would be no surprise at all to say to my fellow public servants in the audience here today that technology has been somewhat frustrating over the years. It's not met our user needs. And a personal view is I believe one of the biggest challenges here is that our security practice has traditionally been divorced from technology delivery, and there's been a lack of focus on supporting the actual user needs that the service exists to deliver against. So I observed that one of the issues that we need to deal with is that we focused our security analysis through the lens of compliance with our own policies, rather than supporting the actual user needs that need to be delivered, or indeed about protecting the things that we genuinely and actually care about. Using ambiguous policies and our own unique terminology within the UK government resulted in bespoke, or if you like, designed specifically just for us, solutions. And that came with some issues. It came with significant complexity, very high cost, and quite often the user experience was pretty poor, interoperability suffered, and ironically, we got less security over time because the technology would age. Now, I'm certainly not saying that compliance with policy has no place, but it does start to become an issue when the focus is on compliance rather than actually delivering against the needs that we have and maintaining actual contextualized security. So if we're going to support the ambitions to change how we work, the digital services that we deliver, and the technology we use, we need to make a paradigm shift in how we approach security. And I think one of the most significant things we did was we totally overhauled our old legacy classification system. It dated all the way back to the Second World War. And we replaced it with a much simpler, much easier to understand three-tier system. And the lowest of those three tiers was the level that we call official. And it's really interesting because it covers the vast majority of government needs. It covers data supporting needs that represent the most basic and routine of administration, right up to needs that are towards that national security boundary. And because we had such a massive diversity of need in official, it means that it's just not possible to take a one-size-fits-all approach to either technology or to security. It requires active decision-making by service owners with knowledge of what needs protecting and why it needs protecting. Now, as one of the geeks in the National Cybersecurity Center, we've actually gone on quite a transformative journey ourselves. We genuinely get that government is here to serve the public, and its purpose isn't to implement our arbitrary security rules. And so we developed a new mantra, and this was quite counterintuitive for us. We developed this mantra that says, user experience should be fantastic, security should be good enough. And that's quite culturally challenging for a security professional, but I really like this statement. I really love it. And why I like it is because it absolutely underlines our commitment to helping colleagues like Tom, who's going to come up on the stage shortly, deliver excellent services with the security that he needs as the senior official responsible for that service. OK, so I've discussed our security philosophy a little, and now I'd like to illustrate this with our approach to cloud. I think it's pretty reasonable and fair to say that there still remains a fair amount of mystery and, dare I say, prejudice towards cloud and cloud security. We need to remove some of that fog if we're going to help decision makers make active and good decisions. We need to give people the tools to reason about their security meaningfully, and we need to help them describe the security requirements in a consistent way that can be understood. We did this through an approach we describe as our cloud security principles. There are 14 of them. It's really important to say these are not standards. These are not requirements. It is not possible to be compliant with the cloud security principles. What they are is 14 areas where a security decision needs to be made. Plus, we provide a whole range of information and guidance about the implications of the various decisions that it's possible to make as well. And the best bit about them, they're written in plain English. They're very easy to understand at the high level. And our aim here is to help, as I've alluded to, help decision makers make informed decisions. And so with this clarity of understanding, plus our needs described in a consistent way, it starts to become possible to compare the security needs that we hold with the attributes of the services that are available in the marketplace. Now, a number of vendors, including Amazon Web Services, publish a lot of guidance, a lot of information that describe the security attributes of the services they provide mapped back to our principles. And this is great. This is great because it's really helpful for our customers in the UK to understand how these services can meet their needs that they've defined using our framework. And similarly, whilst we do not mandate the use of any particular compliance certification, many of the services hold certificates, and it can actually be useful as a tool to demonstrate confidence that the security attributes that you care about are well implemented and are accurately portrayed. Now, finally, it still remains the case that there is a number of myths regarding cloud service security, and these myths represent still a significant barrier to adoption. And it's something we're trying really, really hard to bust. Actually, we spoke about some of these in a bit more detail earlier on today in the security track. So I'm just going to touch on three of the really significant ones as we see them right now. Firstly, it's often said to us that due to the global nature of a service, it's somehow inherently less secure than if exactly the same service was hosted in a data center in the UK. But actually, that just doesn't stand up to technical scrutiny outside of particular national security type applications. People often say to us, yeah, but you can't know who's got access to your data. And that's a legitimate question to ask, but actually it's one that service providers take incredibly seriously. Most service providers provide an extraordinary amount of detail and information that describe how they manage that particular issue. It's usually the case that very, very few individuals have got the facilities and the ability to access data, and that if they do, it's very, very heavily audited. And of course, you should be using encryption services anyway. Finally, I think it's legitimate to look at how infrastructure is maintained, patched, and operated. After at least 10 years of giving advice to many public sector organizations in the UK to patch, we've reached the conclusion that we're not actually very good at it. So if we can rely on a competent cloud hosting provider to do some of that for us and to do it well, and we don't need to worry about it, we believe that, on average, this can help us to deliver more secure services. OK, so putting it all together, we've moved from an approach of compliance-based security through to one of understanding your actual needs, actual security needs. We've developed an approach to help organizations determine the security needs for themselves using our frameworks. and we're helping government departments to make informed consumption decisions. We've changed our approach. And I'll be delighted to welcome Tom up to the stage, who's going to demonstrate how the Ministry of Justice have used that approach to deliver some awesome services. Thank you.
All right, good morning. My name's Tom. I'm the Chief Digital and Information Officer from the Ministry of Justice in the UK. As Ian said, I'm going to talk about the two big blockers we have traditionally had in government of getting really good digital services. One being terrible infrastructure, and two being overzealous security engineers and the Department of No. And I'm going to talk about how AWS is helping with the first, and colleagues from the National Cybersecurity Center are helping with the second. A little bit about the Ministry of Justice. That's our mission. We're protecting and advancing the principles of justice. Parts of the Ministry of Justice date back to 1178, so we've got quite a lot of legacy. We employ around 70,000 people. We operate 500 courts and tribunals across England and Wales, 133 prisons, and we look after 85,000 people who are on remand in prison. And I want to tell you about a couple of stories about how we've gone on a digital transformation journey. So traditionally, government CIOs in the UK were kind of infrastructure managers and supplier managers. You know, it's all about sort of getting, sweating your assets and worrying about your data centers being backed up and redundant and that kind of thing. And then in 2010, we got a new government, and we had the Government Digital Service formed. And we had a completely different breed of people come in. People like Liam Maxwell and Mike Bracken came into government and switched the paradigm overnight. So we went from being like traditional CIOs to people focused on the end user, and we were really focusing on user needs, not government needs. What this means is building digital services so good that people prefer to use them, not just because it's a hipster thing to do, but because we can't afford to operate big walk-in centers and call centers anymore. We had to move to authentic digital services. So I'm going to give an example of, we do a lot of things in MOJ, but I'm going to talk about prisons, because that's where a lot of our really, really sensitive data is. So one thing we're really focused on is rehabilitation, getting prisoners to reform themselves while they're in prison. And that's not just, again, because we're nice, obviously we're nice, but the real reason for that is economically, reoffending costs the UK somewhere in the region of £15 billion per year, so sort of $19 billion per year. It's a lot of money. And that's because we put people in prison and then they sort of learn to be criminals and then they come out and they reoffend. And what we did is we did a lot of studies to work out what drives people towards reoffending and what enables people to transform their lives. And we saw a really, really strong correlation between prisoners maintaining contact with their families and getting visits and not reoffending. In fact, we saw a 38% reduction in what in the US I think you call recidivism when people had family visiting them in prisons. It's a huge, huge stat. It's like causation rather than correlation. So what we had to do is go out and build a digital service to help enable that outcome. Now, we didn't have time to go and stand up a new data center and sort of buy a bunch of racks and some servers and some, get a storage array and, a sit environment and a live environment. We just didn't have time for that. We needed to move really, really quickly. So what we did is we spun up a greenfield digital service, visit someone in prison. And this allows citizens, family members to easily book a prison visit. And it's a really nice service, and we got really, really high satisfaction. So that's a good thing. But it wasn't really delivering the outcome we wanted, because while it's lovely and it works really, really well on mobile devices, it's actually just a paper form turned into a web application. And in the back end, it's still paper. So an email gets pinged to the prison officers, and they need to key it into the monolithic application in the back end. So it's not really digital transformation. That's just building websites. So we're like, right, we need to really think this through. And what we did is we took our multidisciplinary agile development team and we set them a new challenge. This is the mission patch. I don't know why it's got a bear, but it does. But these are the integration pioneers. So we set them a challenge. Take that legacy monolithic application in a physical data center and put an API over it. So they built an API using AWS API Gateway within a few months, and it hooks into that legacy application and exposes all the good bits out. Now when you use the service, that's end-to-end. So a loved one books their prison visit, that goes all the way through into that system, and that's ready to go, and the prisoner can see that information within a few minutes with no human intervention. So that's a good thing. Much more exciting, though, we suddenly realized we've got this API that we can use for other things. So we're now standing up new digital services using the same API gateway. So the next one we set up is send money to a prisoner. I don't know if anyone here has been in prison, don't put up your hands, but having access to funds in prison is super important, because otherwise you go down really, well, you've all seen movies, right? But you go down really bad pathways. So this allows people to send money to a prisoner in a really, really secure way. And that's integrated through the AWS gateway, and it's integrated into gov.uk Pay, which is a government digital service platform. So that's a really good service. And that helps reduce violence and all those sort of tensions in prison. Next up, we've got an alpha service in just one prison at the moment around moving people safely. And I've used this example because you don't get much more sensitive information in this. This is like a prison officer transporting somebody between a prison and a court, say, and they have an iPad with information about the offender. What is their mental health status? What kind of crimes did they commit? Are they likely to hurt themselves or somebody else? Do they have some really, really dodgy opinions? And basically that information allows them to, in real time, assess the risk and work out who to put who with who. So that's a really good service, and we're hoping to roll that out further. And again, that's dependent on that API gateway. Finally, well, I say finally, there's going to be loads of these. The next thing we're going to do is try to bring the 85,000 people in prison into the digital revolution and give them the opportunity to manage their own affairs. So allow them to do their own self-service for things like their phone credits and their money, and book their learning and their classes. Give them some of that autonomy back. Start treating them like humans rather than like cattle. This is going to be rolling out in a few prisons soon. And we're really excited about this. We think this can completely transform the way that we approach incarceration in the UK. OK, that's about it from me. So hopefully you've seen how the complete transformation and approach to cloud security that our colleagues in the National Cybersecurity Centre have been helping us with. It's just enabled us to use things like AWS to really quickly iterate and build amazing digital services with a really powerful mission. OK, thank you.
Thanks. Thank you. Amazing. Great stories. I want to latch on to something that Ian said. There is this sort of an illusion out there that getting access to physical systems gives you more access to information than the kind of things that cloud can give you. And I remember a number of years ago talking to a financial services regulator who in their requirements had the right to inspect after an incident. And the right to inspect meant that if an incident had happened at its financial services organization, then this team from the regulator could get access to the hardware to inspect what had happened. And of course, in the cloud, there is no such thing. Even if you could walk into our data centers, which you can't, even I can't, you would not be able to identify any hardware that you were running on. Then we demonstrated to the regulator the kind of information they could get through CloudTrail, which was so much more detailed than they would ever have been able to get through inspecting the hardware, that they were just blown away. And that's one of the reasons why many of the financial services regulators around the world are now approving AWS as a platform for building banking and retail banking and risk management and other financial services on. So if I think about one of the things that often gets mentioned is that people start to consider cloud because there's all these cost savings to be had. Well, that's true. And that will be important forever. Nobody will be saying 10 years from now, oh, I love AWS, I wish they were more expensive. It's not going to happen. But many of our customers, even though sometimes they come on board initially with the idea of cost savings in mind, will pretty quickly tell you that speed is the real reason why they're in the cloud. The ability to move fast, the ability to have an idea about sort of a financial gateway to your prisoners and actually implement it and deliver it within a few months. And so on one hand, that is of course really having the ability to have access to unlimited resources. Yeah? One click of a button and you get these 10 or 100 or 1,000 servers, no matter how much you want, within a matter of minutes. Very different from the 18 months or 6 months, or I don't know what kind of lag time your organization has, but definitely not as agile as that the cloud can give you. That's definitely one part of speed. But what's more important in speed is actually having a wide variety of services available to you. I really think that the breadth and the depth of the AWS services is what drives speed. The fact that you can have an API gateway, the fact that you no longer have to do search. You want to do mobile development? A whole range of services for you. You want to do IoT? You want to do data warehousing? Do you want to do custom analytics? Do you want to do DevOps? Any and all of these tools are available for you on AWS. And it's really our mantra not to tell you what to do. We're not telling you how you should develop. We're giving you this toolbox where you can pick from so that you can find exactly the way that you would like to develop your systems. We're not as arrogant to tell you that we know how you should best develop. No, we make sure that you have all the tools available, that you can pick and choose exactly what you want to do. And also, that you can make mistakes. Feel free to make mistakes. You pick the wrong machine type, then you just decide which other machine type you want. You click another button, and you have at your fingertips what you want. In all of those services, that's very small box at the bottom, sort of that what we were about 8-9 years ago, purely focused on infrastructure as a service, compute, storage, databases. Already, if you look at that very small box, it has such a depth into it. So many different services available there, so many different instance types. Just look at compute. It is not just these families that are there. Within these families, you have all these different sizings as well. And so, if you've made a mistake, and you thought that your application was actually CPU bound, but it turns out to be IO bound, you just switch instance types. Do you want to build something that starts off small, but one needs to grow over time? You don't need to buy the biggest machine immediately. You can start off with something small and then grow it. Go to 2x, go to 4x, go to X for 8XL. All these choices are there available for you. So the breadth and depth of this makes that you can do exactly the way that you want to develop, not how we as a provider provide that to you. If you look at these compute instances, they're really powerful. One of the most powerful ones in this line actually is the numbering. We're now 11 years in, and for example, we are already at C5. That means this is the 5th generation of our compute-intensive environment. If you had to buy hardware yourself, you probably will be stuck with it for 3, 4, 5 years, whatever it takes to actually pay back, get your value out of that hardware. In the case of AWS, you can get the latest and fastest hardware at any time. Meaning that you can always make the right sort of trade-offs between power, I/O, memory, and cost at any time. It might be that at one moment you're running 2 M4s, you might be able to replace it by 1 C5. And this is an environment where you can exactly pick and choose what you want to use to build your systems. So whether you want to have the general purpose ones, the M4s and the C5s, whether you want to do memory intensive, whether you want to run SAP HANA on an X1, whether you want to have GPUs for graphics processing or GPUs like the P2s for doing deep learning, or if you just have a generic processor that's where your power is, but you want to sometimes add a GPU to it, you can make use of elastic GPUs. And recently, we launched a new family type. It's called the F1s. It's basically FPGA arrays. It basically means that sometimes you can develop software in such a way that you can make it hardware accelerated. And so this hardware acceleration can be significant. And so whether you use you can develop on your desktop, you package as an image, and then load it onto the F1s, and go really, really fast. For example, quite a few of these images are available for you in the marketplace. And so these are sort of common use cases. In the marketplace, for example, there is a real-time live video processing image available for you that can speed up video processing by well over 30x, sorry. An AWS partner, ADCO Genome, they've developed this Dragon genome processing platform for the F1s as well, which also gives you a 30x improvement while remaining HIPAA compliant. Really important. So with all of this speed, all of this the ability to move fast, I want to take one step back, really thinking about where do you move fast? It's not in production. Production is often not where your real agility lies. Your real agility is in dev and test. Because that's really where you have to move fast. That is where the agility of your organization is. Often dev and test is seen as sort of a not really serious workload. This is probably the most serious workload in your organization, because that's where your ability to be agile and move fast really lies. And AWS, I think, excels really in its support for dev and test. I've been talking to a lot of CIOs around the world and asking them about what percentage of their budget goes into dev and test. And we hear numbers between 60 and 70%, easily. You can drop that down to 20 to 25% of the budget by using AWS, while improving developer productivity 2 to 3x. And its ability to move fast in dev and test is really important. At reInvent last year, Air Force Lieutenant General Graves talked about their new GPS positioning system that they were building, and how they were running behind because they were doing this on-premise. By moving over to the cloud, he was able to get this first IL5 workload in the cloud running, in the public cloud running, in AWS GovCloud, and bring the project back on track. It really is a demonstration of how dev and test in the cloud allows you to move fast because you're no longer constrained. Now, with all this talk about instance types and things like that, there is actually a real move to sort of moving away from these lower levels of compute. Really, the superpower is there, that of invisibility. And if I look how development is changing, we used to be building these monolithic applications. But there was a challenge with these monolithic applications. Because some of the pieces of these applications, if they needed to scale, were really driving the scale where maybe 80% of the rest of the application they did not need that level of scale. And so we started to decompose them into smaller building blocks. And then actually taking another step to a much more finer grained building blocks, where each of those building blocks had unique scaling and security and reliability requirements. And so this concept of microservices really helps you to think differently about your software, where you sort of decompose them into those building blocks where you know exactly what kind of scaling requirements they have, or what kind of security requirements. Let me give you an example there. Amazon.com, the retailer, had a monolithic application that was cut up into services, smaller building blocks, in the beginning of this century, just 2000, 2004. But we'd actually built a number of large services. One of them was what was called the Customer Master Service, that held all code that operated on the Customer Master database. Now, in that code, there were components that, for example, were called on every page or every login. And there were other components that operated on the customer's address book that only were used during checkout. Both of those have significant different scaling requirements and also security requirements. But by putting them in one code, the code that actually had access to the address book also would have access to the credential store. By decomposing these into smaller building blocks, we're able to create an environment where those services that need very high scale and high security, because they only need access to the credential store, can now be separated from those components that may have less scalability requirements or maybe less reliability requirements. So decomposing into these small building blocks gives you better fault isolation and better security. Now the whole rise of microservices is really driven by the rise of container technology. But if you look at modern container technologies out there, especially the open source ones, I like to believe that they are really lacking in capabilities. Mostly because if you look at them, they bring you back to sort of the pre-cloud days. Most of those container management systems means that you suddenly have to start managing this whole environment again. You have to decide where to place your containers. They often don't give support for automatic placement over multiple availability zones. And they definitely force you to give up security. Because now suddenly this system has no fault isolation, no security isolation. So I think that Amazon EC2 Container Service, ECS, is the absolute best way to run your containers in production. And why? One of the most important things in there is the deep integration with all the other AWS services out there. Yeah, whether it's EBS or ELB or CloudWatch, the integration with them, it means that if you run your container systems, you do not suddenly have to give up on security. Or you don't have to give up on reliability. Or suddenly you don't have to run tools like Zookeeper to actually make sure that the whole thing is fault tolerant and runs over multiple availability zones. Using the tools that AWS already gives you in combination with containers become really powerful. You can use ALB to run prefixes, traffic directly into a particular task. You can make use of CloudWatch logs to get all the output from a particular task to one particular place. You can use IAM to actually decide that this task only should have access to the credential store and that task only to DynamoDB. As such, ECS is really the absolute best way to run your containers in production. Especially because this whole set of actors around it that help you get you the real power of AWS, the depth of AWS in your hands. Many of our customers using the container systems, Coursera, of course, is a well-known one from here. But for example, if you take Blackboard or if you take Nextdoor, Nextdoor is an interesting story because they were running on EC2 VMs first. But moving over to ECS, they could such a more dense placement of tasks onto their VMs that they reduced their cost easily by 50% just by moving to a containerized system. We've all this talk about still mapping tasks to containers and to VMs. It's actually still a step further that we can take, because if we look what the real power of AWS was that you actually don't have to think about sort of these multi-AZ deployments. If you look at what sort of the real power is of many of the managed services in AWS, is that you don't have to provision, you have to manage them. It scales with any usage that you offer it. Has fault tolerance built in automatically over multiple AZs. And as such, the whole notion of serverless is really driven by this whole collection of managed services that AWS offers you. Now with all of that, given that we've had these services for quite some time, there really was one piece missing. And that piece was compute. How to do serverless compute. For that, we offered you AWS Lambda, which means that you can write code, whether you run it in Python or in Java or in JavaScript. You can just run this code without having to think about servers or VMs underneath there. It really becomes managed compute for you. We make sure that whether you want to run one instance, one function, or 10,000 functions in parallel, that you don't have to think how to do that. That will automatically make it fault tolerant by executing it over multiple AZs. And so this was really the missing step to create truly serverless systems. And we've seen not just young technology businesses immediately jumping on this, but we actually see quite a few organizations mature organizations immediately knowing what they could do with AWS Lambda. FINRA, for example, who has to inspect all market data that is created on each day, easily takes with it 75 billion events coming from the markets each day, and each of them becomes one AWS Lambda invocation. They don't have to think about what kind of fleet of EC2 instances they need to run for this. The computation is really managed for them. I think if you think about all of these systems that have been built, there's probably one thing in the back end that they all have in common, and that's the use of DynamoDB. DynamoDB is our non-relational database. That's probably one of the true proponents of serverless. Because when we started building DynamoDB, we really thought about what kind of management interface should we give it. Because we looked at all the other NoSQL databases, and they all had really complex management interfaces. Buffer caches, connection pools, things like that. And we thought, what is it really that you want out of this? What do you really want out of such a complex configuration environment? And it is consistent performance. That is why we're doing all these things. And then we started thinking, why don't we then just give it an interface that allows it to have consistent performance? So that you as an individual no longer have to think about how to configure all these different variables, but just tell us, this is the number of reads and this is the number of writes you want to do, and we'll make sure it will have consistent performance for you. DynamoDB, great success, and I think the recent launch of VPC endpoints make it even more powerful. Now you no longer need to go over the public internet to access your DynamoDB instances. However, we see a real change happening in a range of applications for which this consistent performance of DynamoDB, which I think around writes sits around 5 milliseconds, is no longer good enough. There's a whole range of applications that say algorithmic trading, these advertisement systems, gaming, for which milliseconds is not good enough. You really need to go to microseconds. And what we see, quite a few customers that have been built these systems on AWS were putting a lot more complexity into their environments. They added caches. Most of these caches didn't have the same interfaces as that Dynamo had, so they had to change all their codes to be able to be cache aware. Many of these caches are not fault tolerant. So we took a look at that and thought, we can solve this for you. So we added something to DynamoDB, which is called the DynamoDB Accelerator, DAX. So with one click of a button, you can now put an accelerator in front of DynamoDB that drops your response times for your reads from milliseconds to microseconds, a 10x improvement. And it's really by one click of a button, and most importantly there, it has exactly the same interface as that DynamoDB has. So you no longer need to change your code if you want to go from milliseconds to microseconds. Now, these NoSQL databases are extremely powerful, but quite a few of our customers are still running traditional relational databases. And if I think about relational databases, there's one thing I want superpower, and it is flight, to fly away from them. Yeah? Mostly not because of the technology or not because of the capabilities, but it's mostly because the way that the vendors of these old world databases behaved. And I've been on the receiving end of this. And I've had to write this check to these large database companies long time in the past. And when I did that, I never felt in charge. I always felt that the vendor was in charge. The only way to drive costs down was to make these very long-term contracts, 5, 10 years, and often you were overbuying your number of licenses because of the punitive actions that we're including in the contracts. I really wanted to make sure that I would never get into this area where this vendor would take action against me. And so I've heard this by now quite often from many other CIOs who say that they frequently buy 30% more licenses than they really need to avoid this "you've got auditing" email that comes from one of these vendors. And I recently heard that one of the vendors even increased its price by 2x if you want to run your database in the cloud. Well, this drives why many of our customers actually want to move from one of those commercial databases and move over to some of the open source ones. And we help them with this, with the AWS migration service. Since the launch of that, we've migrated 26,000 databases from on-premise into the cloud. And a number of them are between the same type of databases, but quite a few of them are between these commercial proprietary databases in the cloud to open source ones on AWS. Many of our customers have ever asked us whether we couldn't help them with creating a database that would have sort of the enterprise-grade capabilities in terms of reliability and performance, but still at open source cost and at an open source framework. So for that, we created Amazon Aurora, which actually is 5 times as fast as the highest end MySQL that you can build, and actually is at 1/10 of the cost of any of these commercial grade databases. And the capabilities of Aurora behind the scenes are superior to any of the other databases that you can have out there. Because this is database technology that is created now in 2016 instead of old technology that has been extended from the 90s. We replicate, for example, each data 6 times over 3 different availability zones, always giving you low latency access to the capabilities. We now also added PostgreSQL as an interface to Aurora, because it makes it easy for quite a few of our customers that want to move from these commercial grade databases over to an open source one, because PostgreSQL is more or less semantically compatible with those. Again, already many of our customers are building tremendous systems. You probably know Expedia. 150 travel websites around the world. Expedia, as its backend, has Amazon Aurora. It does well over 300 million rides a day, up to peaks of 17,000 rides a second, capping it at 50 milliseconds rides response times. Reads multiple times of that. Billions and billions of reads that are all happening at well under 10 milliseconds. So Aurora has demonstrated really to be one of the more powerhouses in cloud databases today. Now, you need to do something with your data. And I think there's nothing more important today than doing analytics. We see a real sea change happening in many organizations. Data is becoming the big differentiator between companies and organizations. Yeah, so everyone now has access to the same level of computational power, the same analytics engines. So now the competitive differentiator really is becoming, what do you do with your data? What is the quality of your data? What kind of queries do you ask your data? So for us at AWS, it's really important to make sure that you have all the right tools in your hands so that you can choose exactly what kind of analytics you want to run and how you want to run it. And also on any type of data set. So X-ray vision really helps you to look inside your data. So we have 3 different types there. Interactive querying, custom-made analytics with EMR, and data warehousing with Redshift. Now if we look at Athena, this is our interactive service. You store your data into S3, and you can run standard queries against the data that sits in S3, and where you only have to pay for those queries that you really run. It's excellent for example, running ad hoc queries without actually having to have any long-term structure around it. Sometimes you really need to build very dedicated, exclusive analytics that are specific for the kind of applications that you have. EMR, with all the set of open source tools around it, Hadoop, Spark, Presto, HBase, is the real tool to use there. You can run it on clusters that are 10 nodes or 1,000 nodes. You can go as wide as that you want. And then there is Amazon Redshift. our data warehouse service, which is radically different from the other two services. The other two services are way more focused on sort of unstructured data. The Amazon Redshift is really a traditional data warehouse service, where often you pull data out of multiple data sources, and where referential integrity is really important. For example, if you need to run financial results, you need to make sure that your financial tables and your product tables are really talking over exactly the same products. So Redshift is becoming really important for many of our customers to run very complex data warehouse querying. Now let me introduce one of our public sector customers who's using Redshift to analyze Medicaid data nationwide and to look at healthcare trends within that. So please welcome on stage Jessica Can, the director of the Data and Systems Group of CMS.
Thank you.
Thank you.
Thank you. I kind of feel like this is a disco theme, the balls, but I won't scare you off with my dancing. So thanks for having me. I'm your friendly federal bureaucrat, local, like the accent, here to tell you about our Medicaid program, your Medicaid program, and what we've done with AWS. But before I get to that, in order for you to really understand this story, I want to make sure everybody has a little bit of information about Medicaid. This probably won't make you popular at your next dinner party when you share these fun facts, but it'll make me feel better that you know what I'm talking about. Medicaid covers 74 million Americans in health insurance. 74 million, that's more than Medicare. See, fun fact. It covers more than half of all births in the United States and more than half of long-term care for elderly and disabled. So it's clearly a huge payer. And it's mostly children, actually, when you add up all of the numbers. We cover a lot of children. So Medicaid is federally funded for the most part. There's some state match, but it's really state administered. So it's like 51 little Medicares, really, because those states have a lot of flexibility. But that doesn't mean that at a national level, we don't want to be able to answer questions like, so how many of those pregnant women actually got the normal routine of prenatal care? Or where are people going to access behavioral health services? How many people are getting opioid treatment? Those are good questions. Kind of hard to answer when you're looking at 51 separate programs. So about 4 or 5 years ago, we decided to up our game on the kind of data that we collect from and with states to be able to understand these trends across the Medicaid program nationally. Because it's, I should have mentioned, also about $500 billion a year. So good to know, little metrics in there, right? So we increased our data, increased the number of variables, helped states, bring them in, and we were thinking all along, like, this is great, these are the questions we can answer, and this is what we're going to do. And as we started to do the federal bill, that federal catcher's mitt, we started to think about the size and scale of the data. I mean, seriously, just California alone would probably jam up our data centers, right? And we knew that this wasn't data just for data collection's sake. This was data to use. We wanted to be able to answer those questions and to have a data-driven culture. And you don't get a data-driven culture if the blue circle of death comes up and you wait and you wait and you wait and you wait for that query, right? You've lost your people. Because most of the people I'm trying to bring into this culture are not data wonks and data scientists. Most of them are policy people. So performance was really important and not competing against everything else that CMS does and has in its bandwidth. And size and scalability was really important because the data is cumulative. We weren't building just for now, we're building from 4 years from now. So just to give you a sense, we have about 72 terabytes of data, and we're bringing in 5 more years of California right now, historic data. So just California alone is 900 million records a month. So I just wanted you to think about how fast we're going to get to a crazy amount of scale, and that we can't have any compromise in that ability to answer the questions, right? That's the point. Who's getting prenatal care? how many kids are getting vaccinated, where do we have access issues, what's the treatment patterns, what are our highest cost drugs, important questions. So we had, at this stage, a Silicon Valley startup firm working with us. See, it can happen, government and Silicon Valley startups, it can happen. And they said, natively, like in their initial proposal, we can build this for you. This is kind of easy. This is a mosquito bite for like the Google people, right, in terms of how much data. But we have to do it in the cloud. Well, CMS had done a little bit of stuff in the cloud with AWS, but never with personal health information. So here I come with my security team trying to convince them that we should be the first to put 74 million Americans' data in the cloud for performance, for use, and I didn't have any concerns about security because I knew about all my other federal peers, DoD, many others who had gone ahead of us. But it was still an uphill battle. We still have a lot of course, important high security requirements, and because it was the first time at my agency, there was a lot of trepidation. So that was fun. But we got through that, and now we actually have it up, and now it's considered a landmark, and others are moving to the cloud with their data at CMS, regardless of whether it's PII or PHI. And our infrastructure itself, supported with some of the vendors I saw as I walked through there, Databricks and so forth, and we're using Amazon Redshift. Part of that infrastructure now, we have other federal agencies coming to check it out, and to say, how do you do that, and how do you produce it? Because it's this constant influx of very complex data from, as I said, 51 different paths that we did try to get them to a single data dictionary, which is like matchmaking times 51. And we brought them all in, and every time we ingest that data, it has to go through very complex business rules to make sure that the data has some sense to it. And also flagging things that we may need to look into. So it's quite a big enterprise, but it's already producing. So we've already shared the data with our oversight bodies, like the Congressional Budget Office, and MacPac, which oversees Medicaid from the congressional perspective, and with the US Census. We're looking at it already for fraud and abuse for those Medicare and Medicaid participating providers, having an impossible day where they saw 40 patients on each program, that kind of silliness. And we've given the data to a technical experts panel to really dig in and understand states' data quality. Because to be clear, what we've built with AWS is an operational data set. It's not academics. We're not going to this isn't clinical trials, not dissing those things, but this is an operational data set. We need to use it as it comes in, and it will never be perfect. I tell people that all the time. I know it's a downer, but this data set will never be perfect because it's real, and that's how healthcare data is. People submit claims, and they argue with the payer about that amount, and it goes back and forth, and it's a while before you get that final claim. And in Medicaid, we can have retroactive eligibility back 90 days, so people's start date isn't exactly their application date. It can be messy. State systems have problems or go up and down, the managed care plans change. But if we have real transparency into what is and is not there, then we can tell you what to look for. So now you're informed consumers with that data. So what AWS also allows us to do, besides running all those tools and edits so that we can see the good, the bad, and the ugly, it also lets us share the data in a more creative way. I mean, this is, as I said, massive amounts of data. It's not like I can put it on a thumb drive or just post it on cms.gov. There need to be ways that we can share it more creatively with our partners. And so we are exploring many options, but one of the ones that I find most exciting is the peer-to-peer. There are other federal agencies who also use AWS and also need this information. That would be a lot easier for me. Can we push things into S3 and have people do downloads? There's a lot of options for us. So again, it's all about performance and use. And I'm happy about the storage. I like the pay-as-you-go. I used to have to pay a lot of money for database space that I never actually used. That's not fun. So that does help. It does sometimes challenge you in predictive budgeting, but we're working on it. But really for us, and back to that original company, for them it was a no-brainer. That was part of our solution. And there were so many FedRAMP-approved products that we could integrate with all our business intelligence tools. They were sold. We got our security people sold. And now we're working on the data-driven culture and getting people to use the data and ask those questions and understand the quality of the data as well as an ongoing operation. I have the privilege of serving the Medicaid program and leading our data and IT work. And this project that I was talking to you about, the Medicaid data, is just the first of many. We're building all of our other systems in the AWS cloud as well, because ultimately we would like to have a shared data model where we can move all of those pieces across. So we've made that cloud commitment. Thank you, ma'am. And we look forward to the ongoing partnership. Thank you. Thanks for inviting me.
Thank you.
Thanks.
Wonderful.
Thanks.
Wonderful story. By the way, exemplary. Not only for maybe public sector, but many commercial organizations are going through the same phase. Knowing the amount of data that they actually sit on, but not being able to take much intelligence out of that. And Redshift plays a very important role there. Customers really love Redshift. As you know, at AWS, we really thrive on the feedback cycle. Customers continue to give us feedback. We continuously improve the services. And so Redshift probably has been that service that has iterated most quickly. Customers really love this. And so they're using Redshift all over the place. And so for example, Ivy Tech Community College in Indiana is using Redshift to predict student outcomes and then intervenes if those outcomes are not satisfactory. And so they're seeing a decrease in student drop rates and an increase in graduation rates just by being able to use the data that they already have. Now, with all these feedback cycles that we get from our customers, there was one particular question that they really asked us for, because we see an enormous rise in data sets, in sizes of data sets. Exabytes, petabytes are normal today. And so loading a petabyte into Redshift is a challenge. And so customers are asking us whether we couldn't actually load directly out of S3. If you treat S3 like a data lake, let's say that you store all your original source data in there, all the updates that are happening to each of your data sources, then you might want to actually query that directly, because those data sets may be of significant size. So as usual, we put our invention hat on and build a data warehouse that can read directly out of S3. So with that, we built Redshift Spectrum, which is an extension to Redshift that allows you to directly query data that lives in S3. And so what you do, you have the data that lives in S3, you register it with the data catalog, and then in Redshift, you can point to the tables that you defined in the data catalog as external data tables. If you then execute a query, it won't load that data into the Redshift nodes, but leaves it in S3. So this means that you can, on very large data sets, run these very complex data warehouse queries. Well, let's take a look at one of those. I find this is sort of actually a relatively simple data warehouse query. You have 4 tables, so one of them will live in S3, and this is an exabyte table. Yeah? Let me do this, an exabyte of data. The other 3 are local tables, so there might be a fact table, a dimension table, maybe some identity table. And then, you do 8 filters, 3 joins, a few group bys, a limit, an aggregation, and some casts, a typical data warehouse query. If you would build a customized one on this data living in S3, and you use Hive for that, it will take you 5 years using a 1,000-node cluster. Can you imagine what your AWS bill will be after 5 years of 1,000 nodes? So with Redshift Spectrum, it takes you 155 seconds. And I think for a complex query on an exabyte of data, I think a Redshift Spectrum costs you something about $200, something like that. So this is a major departure for someone doing really complex data warehousing on very, very large data sets that live in S3. Now, most of this is sort of looking backwards. I think if I look at sort of different data analytics, there's sort of 3 different styles. I think one of them is sort of the traditional reporting. You take the data and you look back. The second sort of transition is into real-time data, where you're no longer interested in what was your inventory level yesterday, you're interested in what is it right now. Not what your customers were saying about you yesterday, you want to know what they're saying right now. So real-time is becoming more and more important. And the third pillar of that is that to look forward, to take data from the past, to make predictions about the future. And that will be sort of your precognition superpower. This looking forward is machine learning. Basically, you're smart about how you build your applications and your systems. You take data from the past to make predictions about the future. If you're an Amazon.com retail customer, you've been using machine learning services for the past 20 years already. You just didn't know it. Whether it's your recommendations or similarities, all of those are machine learning. And so many different pieces behind the scenes are machine learning. The way that we do inventory level setting, the way that we do fraud protection. We're literally sitting on billions of orders. We would be stupid not to use that data to make predictions about new orders coming in and give them a score of what the likelihood is that this is also a fraudulent order. And so we use machine learning everywhere. And so it's a real powerful tool to make use of data from the past to make predictions about the future. And many of our customers are doing this as well. Take, for example, Netflix. Netflix has claimed that 75% of the movies watched on Netflix are triggered by a recommendation. That makes your recommendation system extremely important. So the core behind the scenes then becomes machine learning, taking data from the past, individualizing it, and then giving recommendations to your customers what they should watch there. So there's areas of machine learning that's called deep learning. Drives much of the talk today about AI. And I think some of the advances that we've seen recently in sort of improving platform services in that area, as well as improvements in hardware like the Amazon P2 instance, has driven a lot of the advancement in AI today. Now, to talk to you about that, I'd like to invite Dr. Matt Wood on stage, the General Manager of Deep Learning and Artificial Intelligence at AWS. Matt.
Thank you. Cheers, thanks. Good morning, everybody. Thank you very much, Werner. So I'd like to take a couple of minutes to talk about deep learning. Deep learning is an approach to building artificially intelligent applications that exhibit human-level intelligence. And the truth is that a lot of techniques used in deep learning are actually pretty old, 20, 30 years old. But they've been held back from being applied mostly through challenges related to scale. The level of data and the amount of data required to train deep learning models is substantial. And the amount of compute resources is also substantial. These are very computationally hungry algorithms. And the dirty secret of machine learning is that once you've trained these models using all of this data and all this computational firepower, you then have to make predictions. You have to infer predictions against those trained models, and that's also very computationally demanding. But the truth is that at AWS, we've been helping customers solve challenges of scale for over 10 years. And today we have customers that have petabytes of data up on the cloud, or even more, exabytes of data. And most new data from web apps and mobile applications or IoT deployments is being generated and housed in the cloud. And everything else is being moved as aggressively as possible into AWS. In terms of training, we provide state-of-the-art GPUs, and a lot of them available with elastic capacity. And for prediction, we've seen customers use both GPUs and CPUs for inference, as well as using serverless environments such as Lambda to drive enormous scale for their AI workloads. And as a result, AWS has really become the center of gravity for artificial intelligence. It's become an engine which has allowed our customers on AWS and our friends over on the retail side of the business to drive incredible innovations. At Amazon, we have thousands of engineers that are working on artificial intelligence and deep learning really across the company. It's become a tool that every developer inside the organization has access to be able to drive new experiences and new products. We use it extensively in fulfillment and logistics, whether that is robotic fulfillment, moving inventory around in our fulfillment centers, or new methods of delivery, such as Prime Air with automated drone delivery. We use it to improve search and discovery. Every search that you do on Amazon.com is driven by an artificial intelligence model. And I'm sure you're all familiar with customers who bought this also bought and personalized recommendations, which are prevalent across the site. We use machine learning to improve existing products, such as X-Ray on Kindle, which looks inside the text to identify the characters and themes of books and show how they overlap. We also do the same with Amazon Video. And we use deep learning and machine learning to drive entirely new categories of products. Most recently with products like Echo and Alexa, which runs up on AWS, the Amazon Personal Digital Assistant, and Amazon Go, our no lines, no checkout convenience store, which is currently in beta in Seattle. It's where I have lunch most days. And this is a computer vision and sensor fusion environment which allows you to blip a phone, walk in, pick up your produce, and then just walk out, and will automatically detect what you've picked up and build your Amazon account a few minutes later. And at AWS, we think about this in a couple different tiers. At the most deepest level, we have a collection of engines built for training and running inference on deep learning, built and designed for mere mortals. So these are engines such as Apache MXNet or TensorFlow. There's hundreds of these, PyTorch, CNTK, I could go on. And these run and train custom models using your own data on state-of-the-art GPUs. We will be a launch partner for the new NVIDIA Volta platform when it becomes available later this year, but also CPUs deploying to connected devices and also running on mobile devices. And we've seen some truly inventive uses of deep learning from our customers. One that I'm particularly interested in is the early detection of diabetic complications. This is a project that Stanford ran. Diabetic blindness is the leading cause of blindness here in the US. It is the leading cause of blindness in men between 21 and 46. And it's entirely preventable in the majority of cases if you can detect it early enough. So what Stanford did was they took some pictures of healthy eyes, such as this one, and they took some pictures of unhealthy eyes. And they trained a deep learning system to detect the very small vascular changes in the back of the eye. And they were able to predict what patients would go on to suffer diabetic blindness and treat them early to avoid it in 90% of cases. We also see FDA-approved medical imaging workloads up and running on AWS. This is the first use of a FDA-approved environment for deep learning on AWS. This is the detection of congenital heart defects. And something a little bit more playful, no pun intended, we see a startup called Huddle, which is running sports analytics using machine learning. So here they're able to take video, which is captured on mobile phones of professional teams or your local sports team, and they're able to provide analysis to identify what plays you should be running, who the MVP is, things like that. Changing gears, we also see the best performing autonomous driving systems up and running on AWS. This is a system created by TuSimple. It provides autonomous driving using computer vision, driving through, in this case, the streets of Beijing. Slightly less sexy, but even more important, they're able to perform per-pixel object segmentation actually on the device using deep learning. So this is a model which has been trained in the cloud, but actually runs on the car. And what they're doing here is they're separating the road and the road markings and everything within it against the cars. And if you start to apply these object detection and segmentation approaches, you start to be able to do 3D centimeter accurate positioning of the car in space. This is a system that, unfortunately, they call SLAM. But it's a very impressive use of just a computer-driven system which has been trained in the cloud and runs on the device. We also see the uses in more consumer-focused uses, such as Wolfram Alpha, Wolfram Alpha is a general-purpose question and answer system which runs up on AWS. You can ask it any questions, such as who recorded one of my favorite albums, Pet Sounds. And you can see here the system knows underneath that Pet Sounds is an album. It knows that albums have artists associated with it, and it goes off and returns information about the artist. And Wolfram Alpha is the system that Siri hands off to for generic question answers. So when we talk about delivering inference against complex language models at scale, when you have 1 billion phones firing requests at you, you need a lot of that scale. So Alpha runs on top of AWS. At the next level up, we have a collection of services which allow anybody to train custom models against data that you already have housed inside AWS. So here you're able to connect to data which sits inside S3 and Redshift and train it with both linear and nonlinear models. And at the top level, our most abstract level of services, we have a collection of AI application services. These are designed for application developers who don't necessarily possess the deep technical skills to go off and train deep learning models, or more commonly don't have access to the very, very large amounts of high-quality data required to go train them. And so at Amazon, we pre-train these models using data that we have available, and we make them available at the end of an API so that any developer can just provide an input and get a prediction on the output. The first of these that we make available is something called Amazon Lex. And this is an automatic speech recognition and natural language understanding service, and Lex is the underlying technology that sits inside Alexa. And it allows any developer to create conversational, lifelike chatbot interfaces for any application. And we see thousands of customers using this in production today in virtually every single vertical market. Freshdesk is a really good example. Freshdesk provide customer service as a service, and they're able to put a chatbot in front of their human agents. And so that customers, when they first call in, start to interact with the chatbot naturally using natural language, so that the chatbot can start to intercept and intelligently route the calls to the human agents. And we see a really interesting use case from one of my favorite customers, the American Heart Association. The American Heart Association run the Heart Mile. This is a run, there's about 300 of these every single year. About 1 million people take part, and it generates over $130 million in charitable donations. And what the AHA did was they embedded a Lexbot to improve the registration experience. So instead of having to go to a website or download an app and fill all these details in, customers could just interact with natural language, voice and text to be able to sign up for the fun run. And they're able to sign up and generate huge amounts of money for the AHA and a good cause. Next, we have a speech service called Amazon Polly. This takes any text and generates lifelike voice. And just like Lex, we've been able to support thousands of different customers in tons of different verticals. Duolingo is one of my favorites. Duolingo support 170 million people in learning a brave new language. Or the Washington Post, who have embedded Polly deep inside their content management system so that it's there to narrate every single article that the Washington Post publish. In terms of computer vision, we have a system and a service called Amazon Recognition. Amazon Recognition provides image analysis. All you do is provide the image, and the service does the intelligent part on the back end. It'll provide object and scene detection. So here you can see a scene which, even for a human, if you were trying to, say, describe this to a friend over the phone, would be relatively difficult to do. But you can see that the output from recognition correctly identifies that there's a skateboard, that there's cars, that the cars are parked, that there's a person who is in motion, and so on and so forth. Recognition also provides powerful facial detection, so you can look inside, identify the faces inside a photograph, and we'll do simple facial analysis to determine whether they look happy, whether they're sad, whether they're wearing sunglasses. And we have pretty advanced facial search capabilities. So you can do facial similarity matching. Do these two images feature the same person? And you can also look for people inside large galleries and large collections of photos. And we've seen thousands of developers using recognition to drive really inventive net new use cases. Calibre is a really interesting example. They provide concierge services when you check into a hotel. And all they have is, for returning visitors, they have a small camera which identifies the guest as they return and walk up to the concierge desk, and then they load up all the background information and their name so that the concierge can have a more personalized experience. And they saw an increase in satisfaction rates of up to 80% using these sort of personalized greetings. We see customers like C-SPAN. C-SPAN sends every 6th frame from all 8 of their channels through Amazon Recognition, and they're able to build very quickly, in just a matter of weeks, a online index, an online database of which politician was talking when. They indexed 99,000 faces of politicians and then are able to determine who is speaking when on all 8 of their channels. We also see public safety use cases, such as Motorola Solutions, that are continually evaluating and looking for missing persons using Amazon Recognition. They're able to do this by removing humans out of the loop. Humans are very expensive when they're watching these sort of photos. It's very error-prone and it's very expensive. So removing humans out of the loop and having a highly accurate computer vision system replace them can dramatically increase your capabilities. And a really good example of this is the Washington State County Sheriff. In just a couple of weeks, the Washington State County Sheriff were able to load in a catalog of 300,000 persons of interest. And they went from being able to identify a person in 2 to 3 days down to a number of minutes. And this dramatically increases the response time of the emergency services. In fact, within 1 week of this service launching, they were able to reopen a cold case, and Recognition was involved in his first arrest. So Amazon Recognition has found a niche in enabling public safety use cases, really very broadly from Motorola Solutions all the way through to Washington State County Sheriffs. And I'm very pleased to announce that today we're making Amazon Recognition available in AWS GovCloud. So today, Amazon Recognition is available. You can process all of the images that you have stored inside your GovCloud environment. And with that, I'd like to hand it back to Werner. Thanks a lot.
Thanks, Matt. Great news. Recognition and Poly and Lex are so easy to use that you have all of the machine AI really at your fingertips in high-level services. So we're coming to the end. So what is it that we all want? What is the one superpower that we really all want? I mean, we all want immortality, don't we? Or at least we want immortality as a business. However, that's becoming increasingly difficult. Look at what household names are today. It's no longer the big hotel chains. It's Airbnb that dominates accommodation, also hospitality. Each night, 450,000 people are spending a night in a room brokered by Airbnb. Any hotel chain will kill for these numbers. And so what we see is that it's no longer that for these large organizations, for these large enterprises, the competition is coming out of sort of the traditional other banks or other hotel chains. No, it's coming out of all sorts of directions. And especially in a world where services are being delivered digitally more and more, competition can come from anywhere. At Amazon, the retailer, we know this. If we stop innovating at Amazon, we'll be out of business in 10 to 15 years. And not because there will be another large retailer winning from us. It will be death by 1,000 cuts. Someone will be doing diapers better. Someone will be doing shoes better. You have to continuously focus on delivering the right features and services to your customers and continuously iterate on that to really be on the ball and to be able to survive today. Digital transformation for many of these organizations, and these organizations have already made the decision to move over to AWS because that's where they know they can continue to move fast and deliver new features and services for your customers. Jeff Immelt, who just announced that he's leaving GE as their CEO and chairman, said at one moment that one night you go to bed as a manufacturing company, the next morning you wake up as an analytics and software company. There's probably no better example of survival in a digital age than GE is. Remember that GE is the only company left of the original S&P 500. If you hear the numbers, about 60 years ago, the average lifetime of a company on the S&P 500 was 50 years. Now it is 15. The expectation is that by 2025, 75% of the companies now on the S&P 500 will no longer exist. Digital transformation is not just a nice to have. It is a quest for survival. To reinvent yourself around data analytics, to be able to serve your customers better. And it's not just for these commercial organizations. It's similarly for government, education, and non-profits. Remember that your citizens are used to all these new startups, all these new apps. They have their digital information at their fingertips everywhere. They expect the same things from their government. Government programs shouldn't take 4 years to be delivered. If you have an idea, you should be able to deliver that in 2 to 3 months, just like any other commercial organization is doing that for you. And I like to believe that at AWS, we're the right place to partner with and to help you with this. Because we're listening to what you need, to exactly the kind of tools that you need. If you look at our rate of delivering new features and services, our pace of innovation is incredible. Last year, we delivered well over 1,000 new major features and services for you. All, I say, for 90 to 95%, driven by feedback from our customers, where you tell us exactly what you want. So keep giving us this feedback, and we can help you build exactly those systems that you need to build for your customers or your citizens. So with that, I think there is no better place to build than AWS. So with that, thank you, and go build.